Section 8.4 of your textbook deals with the topic of radical expressions containing several terms. Remember that a radical expression is equivalent to an exponential expression, so the laws of exponents can be used to simplify radical expressions. A polynomial is just an exponential expression that generally contains several terms, so the processes that we use to perform operations on polynomials and to simplify polynomials can be applied to radical expressions as well. Let's first review these processes for polynomials, and then we'll apply them to radical expressions containing several terms. At this point, you can pause the video and try the 5 problems shown on the slide. When you're finished, restart the video to see the solutions. In problem 1, we have 3 like terms to be combined, all of them containing x squared. So we simply add the coefficients 9, 7, and -1 to obtain our answer 15x squared. In problem 2, we again have 3 terms in our initial expression, but only 2 of them are like and can be combined. So we combine 8x and x, and we have the answer 9x plus 6y. In problem 3, we're multiplying 2 binomials. So remember, we can use a distributive process here. First, 2 times 4 equals 8. Then 2 times 5a is 10a. 3a times 4 is 12a. And 3a times 5a is 15a squared. Combining the like terms, we obtain the trinomial 8 plus 22a plus 15a squared. In problem 4, we are squaring a binomial, so we can apply the pattern, the quantity a minus b squared is equal to a squared minus 2ab plus b squared. In this case, our a is 10 and our b is n. So we have 10 squared minus 2 times 10 times n plus n squared, leading to the final answer 100 minus 20n plus n squared. Finally, in problem 5, we can apply the difference of 2 squares pattern to multiply the binomials x plus y and x minus y and obtain the answer x squared minus y squared. Now let's apply these same processes to radical expressions containing several terms. In problem 1, we have 3 terms. All of them contain the same radical, the square root of x. So we can combine them by simply adding 7 plus 2 plus -4. And we have the answer 5 times the square root of x. In problem 2, all 3 of our terms have different radical. However, the square root of 18 can be written in simple radical form as 3 times the square root of 2. And then it can be combined with the like radical term, 5 times the square root of 2. So our answer is 8 times the square root of 2 minus the square root of 3. In problem 3, we can perform the same process we used to multiply binomials. 4 times 9 is 36, plus 4 times the square root of 6. 3 times the square root of 6 times 9 would be 27 times the square root of 6. And then finally, 3 times the square root of 6 times the square root of 6 would be 3 times 6, or 18. Now combining the like terms, 36 plus 18 is 54, and 4 times the square root of 6 plus 27 times the square root of 6 is 31 times the square root of 6. Problem 4, we can use the pattern we used when squaring a binomial. So in this case, our a is the square root of 5, and our b is 2 times the square root of 3. So we have a squared minus 2 times a times b plus b squared. Well, the square root of 5 squared is just 5. For our middle term, we have 2 times 2, which is 4, and the square root of 5 times the square root of 3, which is the square root of 15. For our third term, we have 2 squared, which is 4, times the square root of 3 squared, which is 3. So 4 times 3 is 12. Leading to the final answer, 17 minus 4 times the square root of 15. Finally, in problem 5, we can apply the difference of 2 squares pattern. So we have x squared minus the square root of y squared. But the square root of y squared is just y. So our answer is x squared minus y. Expressions like those in that last problem that have the form a plus the square root of b and a minus the square root of b are called conjugates. The product of 2 conjugates is always a rational number. We can use this fact to help us rationalize the denominator of a radical expression that contains 2 terms. So for example, in the first problem, to rationalize the denominator of 4 over the quantity 2 plus the square root of 5, we'll multiply both the numerator and the denominator by the conjugate, which is 2 minus the square root of 5. So in the numerator, we have 4 times the quantity, 2 minus the square root of 5. In the denominator, we can apply the difference of 2 squares pattern. 2 squared is 4 minus the square root of 5 squared, which is 5. Simplifying the denominator further, we see that our denominator is simply negative 1. So 4 divided by negative 1 leaves us with negative 4 times the quantity, 2 minus the square root of 5. Or we can multiply that answer out to obtain negative 8 plus 4 times the square root of 5. Let's do one final example. Problem 2. Again, since we have a radical expression with 2 terms in the denominator, to rationalize this expression, we will multiply by the conjugate. In this case, the conjugate is the square root of 15 plus the square root of 3. In the numerator, we have 6 times the quantity, the square root of 15, plus the square root of 3. In the denominator, we have the square root of 15 squared, which is 15, minus the square root of 3 squared, which is 3. Which means our denominator is simply 12. Simplifying the 6 and the 12, we obtain our final simplified radical expression with the denominator rationalized, the square root of 15 plus the square root of 3 over 2.